we're going to go back and use the scale drawings that we used in previous videos, and this time we're going to look at making actual calculations. Now, the good part about having our scale drawing estimate is that we can compare it to our calculations to have some idea of if our calculations are correct. So I'm going to look at the same figure that we had for ground case 1, and then we've got this scale drawing, and the scale drawing is actually where we're going to come up with our vectors that we're going to use. And so I'm going to have a vector A, and I need a magnitude and direction. However, the magnitude is what we're looking for, and so I'm just going to have to call that magnitude A. And its direction, while when we did the vector unit we often looked at things east, west, north, south, I'm just going to look at these angles between 0 and 360 degrees. So vector A, its angle is at 51 degrees. Vector B has no magnitude yet. That's what we're looking for. We're solving for its magnitude. Its angle, if we start at 0, is 44 degrees short of being 180 degrees, which essentially means 180 minus 44, and that's going to give us the actual angle measure of this vector. So 136. And we actually have 3 forces acting on this. The third one is the weight. It does have a magnitude. We actually do know its pounds. Its pounds are 600. And we also know its direction. It's going straight down, and we know if we start at 0 over here and go all the way around to this angle, that's 270 degrees. One thing we can conclude right here at the start is the weight will always have a magnitude, and its direction will always be 270 degrees. So we're going to go back and use some information or lessons that we learned in the last unit on vectors. First thing we're going to do is use vector component addition and change these into components, XY components, in order to add and find an actual sum. So I'm going to use my X, of course, is A times the cosine of 51. My Y coordinate is A times sine of 51, and we'll go through this process for each of these vectors. So make sure your calculator is in degree mode, since we're using degree measures and not radian measures. So the cosine of 51 will go at least 3 decimal places. The cosine of 51 is 0.629, and if I multiply it times A, I just get 0.629A. And then I'm going to do the sine of that 51 degrees, and I get 0.777A. I'm going to do the same thing for B. X equals B times the cosine of 136. Y equals B times the sine of 136. So the cosine of 136 came out to be negative 0.719B. That should make sense to you that that's negative, because it was in quadrant 2. Quadrant 2 has a negative X. Quadrant 2 has a positive Y, so when we do the sine of 136, we should get a positive value. 0.69, we'll round it to 0.695B. and then we'll make a coordinate for our weight. This time though, we're going to actually multiply it as 600 times the cosine of 270, and for y it's 600 times the sine of 270. 600 times the cosine of 270 gives me 0. That should make sense. The x coordinate at 270 degrees is 0. 600 times the sine of 270. Oh, negative 600. Again, if you really think about it, the y coordinate at 270 is negative 1, so it was simply a matter of multiplying negative 1 times 600 and getting negative 600. Now, hopefully you're familiar with the substitution method for systems of equations, because that's what we're going to have when we combine our x coordinates and our y coordinates. When I combine my x coordinates, I end up with 0.629a minus 0.719b plus 0 equals 0. So why 0 here at the end? Because the sum of the x directions should equal 0. It goes back to this. Let's add the sum of the y directions and set them equal to 0. So 0.777a plus 0.695b minus 600 is equal to 0. Now, as you go through these, and the more you do them, you can kind of adjust some things that you know happen every single time. For instance, you may not want to type this in every time, because this vector is always going to be 0 and the negative weight. This equation is always going to end up with a plus 0 on the end, so maybe you don't even want to write that down. Also, we want to have this minus 600 on the other side of the equation, so we really want to have it written as 0.777a plus 0.695b. And if I take and add 600 to both sides, it goes away from here, and I end up with equal to 600 on the right. So we've got our system of equations. I'm going to mark through that one so it doesn't confuse us. I will use the substitution method. Therefore, I'm going to, just as a matter of habit, I'm always going to solve the first equation for a. In order to do that, I'm going to end up with 629a is equal to, and I'm adding the 0.719b to both sides, so it's equal to 0.719b. If I solve for a, is going to be approximately, and I'm going to take it to 4 decimal places. So I'm going to take 0.719 and divide that by 0.629. So we'll see what I've got on my calculator here. (1.1431b). Now, I want us to be as accurate as possible, so I am not going to use this rounded value except for at the very end. I'm actually going to use this entire decimal here. That's what a is. It's 1.1431b. I'm going to take that value and substitute it in the second equation in place of a, which means this number that's on my calculator, I'm just going to multiply that as I substitute it in for a. I'm going to multiply it times 0.777. Now, instead of an a there, I've got this b, and I'm going to add that to 0.695, and I've got 1.583 on and on b is equal to 600. Of course, that's 600 pounds is what that amounted to. And I'm going to solve for B. This will give me my answer that I got from a scale drawing, and it should be really close to that answer. We'll go back and look after we get answers from this system. So I need to take 600 and divide it by that. Well, for me, the easiest way to do that is to multiply by the reciprocal of this. Instead of dividing by that, I'll multiply by its reciprocal, which on this calculator, there is a reciprocal button. It's x to the negative 1. We know that's a reciprocal. So I'll take that, hit that button, and it just took my answer, made it the reciprocal, and I'll multiply that by 600. It's not the only way to do it, it's just the way I typically do it. And I got that B was approximately 378.98 pounds. Now I'm going to take the entire number on my calculator, substitute it back in here for B, and simply means to multiply that times 1.1431 times 1.1431. I got an answer that A is approximately 433.22 pounds. Now, I have no idea how close we will be to our scale drawing estimates. We're going to find out. Oh, we are so good. Okay, me. Look at my A, 433.22, 432.43. B, 378.38, 378.98. I mean, I've impressed myself, because I can assure you it will be far and few between that we would come that close between a scale drawing estimate and a calculated estimate. I am quite impressed.